So now we're doing number 6. I'm gonna read you the problem first before I do the problem. So it says a block with a mass of 2 kilograms is forced against a horizontal spring of negligible mass, compressing the spring a distance of 0.2 meters, okay? Now we're seeing an image when the released block moves on a horizontal tabletop, so we know it's horizontal. So we have to do much math for the understanding the slope and all that, for 1 meter before coming to rest. The spring constant K is 200 newtons over meters. What is the coefficient of kinetic friction between the block and the tabletop? Okay, so now we can start getting to work here, and we know that we're looking at a spring force question, right? We're looking at the total spring force. So with that being said, we know that we're going to have to use this equation, right? W, right, being W spring, right, is going to also be, oh, sorry, this is delta K here. Delta K, right? So this is the net. This is spring net, right? Work net. So what we gotta recognize as by getting the spring, right? The work on the spring and then the friction. So we would determine delta K. Okay? So this is essentially what we're gonna be basing our work around. We also need another equation that I'm gonna show you right now that is like this. Okay? With Kx here and Fx here, right? Because this is the equation we're going to be looking at. 1/2 times kx x squared. Now, we don't know all the numbers for this yet, but we'll eventually do because we're going to work it out right now. So the W spring that we originally spoke of, right? That's the net force plus the W friction. Let me write here, friction. Is equal to delta K, right? We said that. But what is W spring? Well, W spring, just the equation I just gave you now, the watered down version, is going to be 1/2 kx, right, squared, minus, right, the spring. Over here. That's not spring S, I'm sorry. It's just this. It's this. That's mg. That's what it was. Sorry. S. And then it's going to equal to kg minus k1. Ki. So K initial, K final. So since we broke this down now, right, we have this, the spring, the friction, and the initial and the final, right? The final, the initial, final minus initial. We will now move it on to, keep that in mind, we're going to move it down and we're going to break it down easier. So we're going to have the change mgs equals to 1/2 kx squared, and then that's going to turn into 1/2 kx squared over gs is equal to this, and then this is the equation we want, right? We wanted to isolate this specific question because we're looking for that. We're looking for how much it is, right? So now we're gonna plug it in. So let me make it nice so we can understand. 200 for the k, right? Then we're gonna put 2 over 10 for the, because we had I think it was, yeah, it was 0.2 mass, hence why we did that. Then we have 2 times 10 times the 5, I'm sorry. So then after we would plug this in, we'll get a number like 1/2 over 8 over 2, or 8 over 20, I'm sorry. So after we have 8 over 20, right, we're going to break this down further. We know we can simplify this into 1/2 8 over, no, I'm sorry, not 8, 2 over 5. I'm looking at my notes here, sorry. So after we have 1/2 over 2 over 5, right, we're going to be left with 210, which is essentially just 0.2. So it's the same thing. We were looking at it. 0.2 is the other number. That was the question we're looking for. So we broke it down originally from this equation. I'm gonna write it out here. You have to plug in the numbers for this equation that it basically gave us. Very simple. And we'll be left with 0.2 at the end after you plug in the different numbers, like the ones they gave us in the problem. Okay, thank you.